Demonstrate today is a code library, basically how to drive the robot using code. So I'll start by adding a random project, which is empty. Now remember, I've said to you guys you're not allowed to use blocks, but you can use code. Now, what I'm going to show you today is instead of going examples, if you go on examples and motors, it gives you a starting point. It gives you a starting point of this. All right, you click on that, you can see the examples. But I want to go show you this thing. If you click on here, it gives you all the functions and their library, a dictionary. So if I go motors, I can see all these functions. I have 1, 2, 3, 4, 5 different functions. So if I click on if I run this one, like motor write 15, 15, 1, based on the description here, it says set speed 15, maximum is 30, but there's two 15. I don't know what those two 15s are. If I run it, it'll just, move for a second. Okay, so now if I'm using the first one, I click on it, it's actually giving me an explanation of what each one of these is. What each one of these is. Now, I'll actually get you to look at the last one for now. So if I go to here, code, if I press add, you can see the code is automatically added. Okay? So what it says here, set the speed of the robot motors in centimeters per second. So what we're looking at here, the 15 is speeds are in centimeters per second. Centimeters per second. So what we're looking at is the reason there are two 15s, because we're setting up the speed for left and right motors. Now, if we look at the first one, if I get rid of the 15, leave it like that, can you see the blocks becomes like, it says left is equal to 15, right is equal to 1. So it is always going to look at the left and right motor speed. So, if I get rid of that one, my left speed, I'm going to make it 20. My right speed is going to make it 20. And then as I code it, you can see the blocks start changing. The seconds equals 0. Let's run and see if it works. Nothing's happening because the format is actually numbers followed by number. 0 seconds. Okay, hold on. That was 0 seconds. If I do seconds equal to 1, let's make it 2. See if that works. It works. All right. So if I try this again, if I press add, it's actually add the same thing here again. So I don't want that. I want to get rid of it. Now let me just clean up the code. So if I go back to the motor, I press add. Now if I do left is equal to 20, right is equal to 20, seconds is equal to 2. And let me run it. So at this stage, it looks okay. I run it. No, it doesn't like it. It doesn't like it. Because the left and right, it's must be just single numbers. Now you can read it. Now the code works. Okay, let's run it. It works. Runs for 2 seconds. What happens here if I change the right motor to 10 and keep the left motor at 20? Let's run the code, see what happens. Ooh, it's actually turned 90 degrees. Can you see it? it's actually turned the robot 90 degrees because one side of the motor is running, which is right hand side is slower, left hand side is faster. It's actually making the robot turn. Okay. That's something interesting here. Now, the next function I want to look at is this one. Turn degrees. Turn degrees. If I go to the next line here and press add. Now I want to actually do this. To better understand the code, it says, so the code is on right hand side. The blocks is on left hand side. Okay? I'll just say new function or new code. So I'll just separate those two. I'm looking at, okay, what it does is turn degrees. So turn right by degrees at speed, radius, and if it's reverse or not. So if I want to run it by changing it, I'm going to go, remember the top code allows the robot to turn 90 degrees, correct? If I want to do another 90 degrees, speed is 15, radius equal to 0. Let's see what happens if radius equal to 0. Let's run it. So it's turned 90 degrees, and then, okay, it did that. So if I get rid of the top code, let's see what happens. What does this thing do? Did you see that? It's actually rotating the robot at its initial position to a 90 degrees. But if I change the radius to 1, see what happens. Okay, nothing much. 2. Now, the funny thing is, what is the radius is in centimeters? Okay. Let's make it 20 to see what is the difference. 20 centimeters. All right. That's what's going on. Okay. You're basically defining what is the radius it is turning at. Okay. So what I want you to do is I've done these two as example. And then what I want you to do is maybe have a look at the rest. Now this one is the more complicated one. It says drive each side of the robot by the distance and speed specified. And then talk about motors. So there is something about average. If I go to the next line and add it here, I'll just add this coding here. And it tells you there's something wrong. Motors move speed, I1 distance. You can read that. Okay, distance in centimeter for the left motor. That is what the speed is. So left distance, left speed, right distance, right speed. And synchronize stop. So you can have a play with this particular one, see what can the robot do. Now, after you explore all this, what you can do is actually you can code the robot to drive in a perfect square. See if you can in a perfect square. It's no longer turning. It's actually once it reaches the end of the thing, it's turned at its rotation and do that. Okay, so it's not there and turn 90 degrees. Remember the demonstration? All right, have a crack at it.